Hey everybody, so in this video we are going to take some time to learn about how to write equations for proportional relationships from word problems. Right, so yesterday we talked mostly about writing equations from tables. Right, so we found our constant of proportionality and then put it into the format for our equations that we're always going to use. So today we're going to expand on that a little bit and talk about how we could do write one of these equations from a word problem. So let's consider this situation. So there's a repair technician, maybe in the mall, who replaces cracked screens on phones. I'm sure you've seen those stands in the mall before. They can replace 5 screens in 2 hours. So there's our relationship. They want us to write an equation that will show the total number of screens that they can repair after a certain number of hours. So our two variables are going to be t for total number of screens and h for the number of hours that it'll take them. So looking ahead, there are really going to be 3 steps that we take here, right? So we're going to take our time going through each one. So as we're going through this, if you could just make sure to jot down the most important things on either your OneNote or if you're doing this on a piece of paper, just make sure you can get these important steps down. So the step 1 that we are going to do, our first step, we are going to need to complete a table. Right, in all the other examples before, they gave us a completed table, right, with different variables and values filled in. But the difference with a word problem is we now have to apply what we can read in the word problem to make our table. So they defined 2 variables for us. Again, a variable is just a letter that represents a value. So we have t and h. So we need to figure out which one is the independent variable, right? That's the one that we can make whatever we want. It doesn't depend on anything. And then on the other hand, the dependent variable, that's the one that's going to change based on the independent variable. So this can be a little tricky. So we just have to think about this. So usually you can get that information from this second part that they always write. So they said, write an equation to show the total number of screens that can be repaired after a certain number of hours. So given a certain number of hours, the independent variable, so I'm going to write that in here, how many screens can we fix? So that is going to be our dependent variable. So again, in our table, we are always going to put the independent variable on the left side, right? In this case, that's our hours, right? We can make hours whatever we want. This technician can work for 2 hours, they can work for 10 hours, it doesn't matter, right? That is not going to affect our problem. Well, it will, but we can pick whatever value we want for a number of hours. So that's why that's the independent variable. The reason screens, the number of screens that they can do, or our variable t, the reason that is the dependent variable is because that depends on the number of hours that he's working, right? If he works 2 hours, they told us he can do 5 screens. And we are going to continue our table by starting with that value. So again, the biggest thing here, I think the most difficult thing in this type of problem is deciding which is the dependent and which is the independent variable. So we'll continue to practice that. So we need to start our table here. So they told us in the problem, again, they need to give us at least one of these so we know the relationship. So they told us 2 hours. 2 hours of work will lead to 5 screens that are repaired. So that's our first row that we can put in our ratio table. And now all we have to do is find a way to fill in the rest of the rows here. This is just like we did late last week, right? In order to fill in the rest of these rows, we just need to find equivalent ratios, right? Or ratios that are equal to one another. And we do that by taking multiples of the ratio we already have. So maybe we want to multiply by 2. That'll give us 4 hours. And then to find the amount of screens that they could repair in 4 hours, we're going to multiply that side by 2 as well. So that tells us in 4 hours, this technician could repair 10 screens. And then we could do it one more time just to fill in the last row on our table. Maybe we want to multiply by 3 this time. So that tells us in 12 hours, which would be a long shift, but it could happen. In 12 hours, this technician should be able to repair 30 screens, right? Because we're going to multiply by 3. So again, just to recap, the new thing that we're doing is taking this word problem and creating the table for ourselves, right? Really, the biggest thing we need to practice is identifying which variable is independent and which is dependent. Because we've done practice with finding equivalent ratios, right? By multiplying and adding rows to the table. So I know we've had practice on that. So hopefully that part wasn't too difficult for you. Okay, so that really encompasses our step 1, which was to complete the table. And again, our independent variable will always go on the left side. Dependent variable will always go on the right side, just to keep ourselves organized. All right, let's look at step 2. Step 2 is to now take our table that we just filled out, and we want to find the constant of proportionality, right? Which is what we've been practicing the last few days. The only difference is before they gave us the table filled out, today we have to work on filling it out ourselves. But finding the constant of proportionality is the same method, right? And we learned that we do that just by taking y divided by x, which again can be shown as the fractional form, y over x, or with the y and then the division symbol, x. So either way. So now is where we get to choose, right? Just like we've been doing. We get to go back up to our table and just pick one of the values on the right. So again, I know we were using h and t as our variables here, right? And if this helps you, you are absolutely okay to do that. You can jot down that as a reminder to yourself. The column on the left, that's always our x's. The column on the right is always going to be our y's. So we pick any value from the right. Whoops. I usually go with the small numbers just to make it a little easier on ourselves. So we're going to take our 5. And we'll come down here. That is going to be the y value that we use. Technically it's t, right? Because that's the variable we're using. But just for the sake of what we've been doing, we're going to say that's our y. And then, again, we want to make sure to use the x that goes with it. So that's going to be our 2. So if you go to your calculator, you can push 5 divided by 2, or you can put in 5 over 2. Both of those will give you the same answer, which should be 2.5 for our k value. So 2.5 is our constant of proportionality. And again, I know we're experts on that, but just as a refresher, what that means is that is the multiplier that gets us from the left column to the right column. So if we take 2, multiply it by 2.5, that will get us to 5. 4 times 2.5 gets us to 10. 12 times 2.5 will get us to 30. So that is what that means. Okay? Our final step here is what we were practicing yesterday. We take all of the things we found so far, and we need to actually write an equation for this. Right? So they were really nice here, and they already gave us a starting point. Right? They put the equal sign in there, and they also listed our dependent variable. So it's up to you if you want to jot this down. The way we start these off, so yesterday we were doing y equals, right? Here it's t equals. We always start with our dependent variable. Right? This equation, t equals, depends on, the first thing we write is our constant of proportionality, right? Which we said was 2.5. That was what we found in step 2. And then the second thing we write is our independent variable, which in this problem was h for the number of hours. Okay? And that is our final step. We've taken this word problem, we've made a table, we found our constant of proportionality, and then we wrote our equation. So what we are going to do now is pause this video. So we're going to pause it, we're going to have the chance to answer questions on this example. And then what we're going to do is break into groups. And with your group, you're going to try and see if you can figure out this second example. Then we're going to unpause the video and come back and check out our answer to this. Okay? So again, we are going to start with some groups and get some questions answered. Okay, so by now, hopefully you've had a chance to chat with your group about this second example. And now we are going to quickly go through the answers. So a soccer team is raising money for new jerseys, and they're doing that by selling candy bars. So they've sold 28 candy bars so far and have earned $98. We want to write an equation to represent the cost for a certain amount of candy bars. So again, step one is to do our table. So independent variable is the one that we can make whatever we want. That's going to be our candy bars in this case, right? We could sell 10, we could sell 500, right? We can change that however we want. And that's going to be represented with the variable x in this problem, right? So that's our independent. Our dependent is going to be the cost, right? Because the cost depends on how many candy bars we sell, right? If we only sell a few, the cost is going to be pretty low. But if we sell a ton, the cost will be pretty high. So that is the reasoning for that. They told us we have sold 28 candy bars so far. So that's our first X value, and we've earned $98. So we can start putting that in our table. Now your group, again, to fill in the rest of these rows, we wanted to find multiples, right? So equivalent forms of this ratio. You could have done it another way. So when I did this, I multiplied by 2 for both of these. That gives us 56 candy bars, will cost $196. And then finally, I did another times 2. 112 candy bars will give us $392 for the cost. So again, if you got different numbers for these rows, that is fine. It just depends what you multiply by. But again, just make sure you're multiplying by the same value on the left and the right. Step 2 is to find our k value, right? Our constant of proportionality. So again, we could pick, I usually go with the small numbers. So we are going to do 98 divided by 28. And again, you could have picked any row in here and any row that I didn't write that your group came up with. As long as you did everything correctly, if you do y divided by x, you should be getting 3.5 as your k value, right? Our constant of proportionality. So you can verify that. Again, all that means is if we take our x value, so 28 times 3.5 gets us to 98. 56 times 3.5 gets us to 196. And 112 times 3.5 gets us to 392. So that's our constant of proportionality. Our final step 3 is to write the equation. So again, what we always start off with is our dependent variable. So I'm going to write a little shorthand here. So we always start with our dependent variable. Then we write our constant of proportionality, which we found in step 2. Whoops, I'm sorry, it's 3.5 for this problem. My mistake. And then we write our independent variable, which is x in this problem. So that is the equation that I hope your group came up with. Again, just break it down into our few steps. I think the most important thing to take away from this is deciding which variable is dependent and which is independent. So again, hopefully we, hopefully you did pretty well with this example. We are going to take some time to answer questions, and then we are going to dive into some fun practice to wrap up class for today. So thank you for trying this one with your groups, and hopefully this video helped you.